Everyone, we are back, and I am not feeling well today, so I'm a little bit under the weather, but it is a little bit fortuitous because we are talking about viruses. So let's go ahead and solve this virus and see if I can kick this virus. So biological material behaves mechanically like a polymer. Length of this, thickness of this, radius of this. Stress strain curve, the virus can be seen in the green curve. I want to calculate the pressure required to fracture the virus. The temperature increases from this to this, thermal expansion of this. What's the change in pressure? Write out the full stress strain tensor because I want the pressure required to fracture it. So the green would be here, and the fracture stress, I don't have any x-axis value, so let's just say stress to fracture. It's probably not really here. You could pick this point, or honestly, I'd pick this point. So about 600 stress at fracture, 600 megapascal. So first, whenever we hear radius and thickness, what do? We got to go and start to calculate some values. So let's go ahead. I have my little notebook pre-set up here. So my Young's modulus is a gigapascal because we are working with a polymer. Our Poisson ratio is 0.4. Our radius is equal to 50 times 10 to the minus 9. And a thickness of 25 times 10 to the minus 10. Is it greater than or equal to 10? Yep, we're good to go there. Fantastic. So now I actually, and I need to put, there's also an alpha equals 4.6 times 10 to the minus 6. Del T equals 40 minus 37. And then ET is equal to alpha times del T. I'm going to plug this in, plus ET, plus ET. Fantastic. Now, the stress at which the material fracture, our hoop stress is our hoop stress is always larger than our longitudinal stress. So I'm going to solve when sig h, set that equal to 600 times 10 to the minus, or 10 to the 6, so 600 megapascals, because that's the stress at fracture. So this would be my del P for that scenario. And then, if that's my del P, then sig h is this, sig L is this. I also will have EH, EL, and we got those values. So our stress tensor will look like, in this scenario, longitudinal will be here, hoop will be here, everything else will be 0, and the same for strain. So we calculated this, we wrote out the full stress and strain tensor. What's the value of maximum shear stress? That's just going to be equal to sigma 1 minus sigma 3, where sigma 1 is equal to sigma h, sigma 2 is equal to sigma L, sigma 3 is equal to 0, divided by 2. So that's going to be my maximum shear stress, so tau max. Wrote out those values. What's the rotation to principal stress state? 0, because we're already there. Maximum shear, 45. Draw the fracture pattern. It's going to look like this, if there's no defects. If I have initial crack size of this, a surface tension, will the virus crack? Can't do it because the surface tension, that is for Griffith criteria. And that is it for question 3. So that's our solution. Nice, quick. Hopefully you were able to bank some time. Thanks. See you next one.